To find trig functions on the unit circle, we're looking at where that angle intersects our unit circle. Since this is a unit circle, we can say that the radius is 1. And if this is our angle, we can draw an imaginary line here, make a right triangle. We can say this side is y, and this side is x. And we can kind of figure out each of our trig functions from there. Sine is opposite over hypotenuse, which is y over 1, just y. Cosine is x over hypotenuse, which is just x, where x comma y are the coordinates of the point where the angle intersects the unit circle. Tangent is opposite over adjacent, which is just y over x. And then cosecant is the reciprocal of sine. That's 1 over y. Secant is the reciprocal of cosine. It's 1 over x. And cotangent is the reciprocal of tangent, which is x over y. There are a few common angles that we're going to need to know the trig functions of. And those angles are pi over 6, which is 30 degrees, pi over 4, which is 45 degrees, and pi over 3, which is 60 degrees. Right? We're also going to want to know the trig functions of what are called our quadrant angles, which are the angles that land directly on one of the axes. This is 0, pi over 2, or 90 degrees. This is pi, or 180 degrees. And this is 3 pi over 2, or 270 degrees. And the coordinates of these points, we could figure them out using our triangle ratios. You can figure them out using triangle ratios. I'll just tell them to pi over 6, our ordered pair, is root 3 over 2, comma half. Pi over 4, our ordered pair, is root 2 over 2, root 2 over 2. For 60 degrees, our ordered pair is half, root 3 over 2. For 90 degrees, we're going straight up, so that point is just 0, 1. For pi, we're at negative 1, 0. For 3 pi over 2, we're at 0, negative 1. And for 0 or 2 pi, we're at 1, comma 0. So we can use those ordered pairs to determine the trig functions of those points. And those are those ordered pairs are also listed on a page in your book. So if I give you something like I want you to find the trig functions, find our 6 trig functions of, say, pi over 4, we can figure those out just by looking at the ordered pair. Pi over 4, the ordered pair where that angle hits the unit circle is root 2 over 2, comma, root 2 over 2. So the sine of pi over 4 is just the y-coordinate, root 2 over 2. The cosine of pi over 4 is just the x-coordinate, which also happens to be root 2 over 2. Sorry, I'm starting to get off the screen there. Tangent of pi over 4 is the y-coordinate over the x-coordinate, which is just 1. And then we can also find each of the reciprocal functions. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent, I should have written pi over 4 there, whatever, is the reciprocal of tangent, which is still just 1. If we think about sine and cosine as functions, both of these have the same domain and range. The same domain and range as each other. Their domain is all real. So you can take any angle and plug it in and get a value for sine or cosine. If it's a really big angle, you might wrap around your unit circle a couple times, but that's just fine. So our domain is all reals. Our range, we can figure out, I shouldn't say y, I should say f of t or g of t. If we think about this, Sine is the y-coordinate, cosine is the x-coordinate of the point on our unit circle. Since it is a unit circle, the smallest value for either coordinate is -1, and the largest value for either coordinate is +1. So the domain of our sine function is all reals. The range just runs from -1 to 1. Now, if we're going around our unit circle, if we go a full circle around, that's 2 pi, and then if we keep going, we start tracing back over the unit circle again. So both sine and cosine are what we call periodic functions. They're called periodic because they repeat. In the case of sine and cosine, their period is 2 pi. So after 2 pi, they start repeating. And you can see that by looking at the unit circle. If we look at, say we look at an angle right here, well, if we go here, that's one angle. If we go all the way around and into there, that's another angle, but they're hitting the same point on the unit circle, and so they're going to have the same trig functions. So that means, if I ask you to find, say, the sine of 8 pi over 3, that's the sine of 8 pi over 3 is the same as the sine of an angle that's 2 pi less than 8 pi over 3, or 2 pi more than 8 pi over 3, or 4 pi more, or 4 pi less, so on and so forth. 2 pi is 6 pi over 3, so this is the same as the sine of 2 pi over 3. And if you look at the chart in your book, it gives you the coordinates of the coordinates at which the angle 2 pi over 3 intersects our unit circle as minus root 2 over 2, root 2 over 2, and so the sine of 2 pi over 3 is root 2 over 2. Okay. If I ask you to find the cosine of, say, minus, I don't know, 11 pi over 2, we can figure out what that is using the period. Cosine of 11 pi over 2 is the same as the cosine of, or minus 11 pi over 2, same as the cosine of minus 11 pi over 2 plus 2 pi, or plus 4 pi, or plus 6 pi. 6 pi is going to be the most useful to us, because if we add 6 pi there, that's 12 pi over 2, and that becomes the cosine of pi over 2, which is one of the values that I'm having you memorize, so you should know that that's 0. So you can use the period to help you evaluate trig functions of angles that are not between 0 and 2 pi. Now you may recall from chapter 1 that we talked about even and odd functions. An even function, the definition of an even function is that if you plug in the negative value, then you get back the same thing as if you plugged in the positive value. For an odd function, if you plug in the negative value, you get back the positive value, but negative. Right? And all of our trig functions are either even or odd. If we think about it, sine is related to the y-coordinate. Right? If we look at an angle versus the same negative angle, sine is related to the y-coordinate. And the y-coordinate of this point is the opposite of the y-coordinate of this point. So sine is odd, and if sine is odd, then its reciprocal, cosecant, is also odd. The cosine function is related to the x-coordinate. If we look at the x-coordinate of this point versus the x-coordinate of this point, you can see that they're the same. So the cosine function is even, and so is its counterpart, secant. And tangent is sine over cosine. So we already established that the x-coordinate stays the same, the y-coordinate becomes negative, tangent is y over x, so if one of those changes sign, then the whole thing changes sign. So tangent is also odd, and therefore so is cotangent. Now this is useful for evaluating trig functions of negative angles. So for example, I know that the sine of 30 degrees is a half. And I can use that information if I ask you what is the sine of minus 30 degrees. The sine of 30 degrees is a half. Sine is odd, which means that the sine of minus 30 degrees is equal to minus a half. If I tell you that the cosine of some angle is 2/7, and I want you to find the secant of the negative angle, we can figure that out. Secant is even. So plugging in the negative value is the same thing as plugging in the positive value. So that's secant. That's the same thing as secant of theta. And secant is 1 over cosine theta. Therefore, secant of theta is just the reciprocal. The secant of negative theta is just the reciprocal of the cosine of positive theta. So we can use the fact what we know about functions being even and odd to evaluate functions of negative angles.